Thank you. Thank you, Robin. Thank you, everyone. Well, I'm glad to be here. By the way, hello, Brussels. Hello, Mom. So, these days, all of us rely on technology to get through the day. So can you imagine working during the worst Ebola epidemic in history like this? In this day and age, we still have to see our clinicians collecting data on paper, then walking to the fence to show this information to someone else because they had to destroy the papers afterwards to avoid risk of contagion. This was not the best use of the limited time they could spend inside the high-risk zone. And this way of working was prone to errors, since it forces people to encode things twice, and then one has to assume that the other person understood everything well, maybe asking to repeat it back to make sure. And this data collection system failed to record information that is valuable, information that we could use to better understand Ebola and find better ways to treat the disease. And this is how one of the few software engineers still working in MSF, found a way to help those in the front line against Ebola. So the aim of this project, ELEOS, which stands for Ebola Link for Emergency Operational Support, was to replace the paper, if not entirely, at least partially, to enable remote visibility to external clinicians into what's happening inside the high-risk zone of an Ebola Management Center, EMC, and to make things easier for the medical staff in the field, because every minute counts, especially when you have a critical situation with a large volume of patients and an overloaded staff, a situation like we saw in Iowa 3, Monrovia.
I feel completely overwhelmed. I feel quite emotional.
I think that didn't work out well. Here we go.
I feel completely overwhelmed. I feel quite emotional because there's some really horrible situations in there. I'm almost horrified by the scale of the center that we are constructing. Like, what we have here, 120 beds, it's horrible. It's horrible what the conditions inside, what people are enduring. It's horrible what the staff are having to do. The risk, the heat, everything. To think that we're going to double or triple this size.
That's not a use of the drones, anyway. So, the project starts in September after Brett, the clinician you saw in the video, arrives in Brussels asking for help. We assessed the different devices and systems, and we contacted the medical staff in the field to have a better understanding about what information was required to be collected. In October, we started developing the software ELEOS in-house, and we outsourced the development of the mobile application to a Belgian company called the Z-Test. We deployed our system in November in Iowa 3, and we decided to finish the pilot in March when we started the commissioning Iowa 3. So how does the system look like? Well, on one hand, you have the patients with Ebola who carry a bracelet inside the high-risk zone, over there. And that's the bracelet with a barcode to be able to identify them. We also have the beds inside the tents identified by using another barcode. And finally, the handheld devices used by clinicians in full personal protective equipment, PPE, to send and receive data via Wi-Fi. Outside, we have a server with a database which runs the backend software ELEOS, and an application called MCL, which allows the handheld devices to connect to the server database via Wi-Fi. We also have the laptops accessing the server via Wi-Fi. The laptops are used to display and enter data in different places such as triage, nursing stations, and so forth. So now maybe you're wondering, A PDA, is anyone still using them? Well, let me tell you why we identified the PDA as the best mobile device for this project. It is resistant to the current solution used in the EMC to disinfect. It withstands 1 meter immersion in water for 30 minutes, and is totally protected against dust. But also it was very easy to use while wearing the gloves as specified by the PPE directive, because data can be entered either by touching the screen with the gloves or by using the buttons of the keypad. And it's also a robust and reliable device which works in extreme weather conditions described by Brett. And actually you can also use it as a weapon. So it is very resistant, so when we say resistant, we really mean it. So how does the system fit into the EMC workflow? Well, first, the patient arrives in triage and he's given a bracelet with a unique identification by medical staff in full PPE. The patient details are entered on a computer using the web application ELEOS. If the patient is confirmed, then he's transferred to the confirmed tent. There, a clinician can scan and confirm patient status and current location during each round using the PDA. At the same time, the staff outside can organize the next round by consulting real-time data in ELEOS. On exit, the patient outcome is also entered in ELEOS. So one of the greatest challenges of this project was actually to make a decision about which data we wanted to collect, which questions to ask on the PDA. And I know we love to think of ourselves as an organization without borders, but when it comes to the scope of the projects, we need to learn where to draw the line. So we decided to collect or to ask questions for which the answers were useful in real time. In other words, we collected actionable data because it triggers follow-up actions for the different teams in the EMC. For example, a change of medical treatment or to request to have more staff going inside the tents. And here we can see how the patient record looks like on the screen of the PDA. There we have the patient details, which are practical to assure you have the right patient in front of you. We also have the patient location given by tent and bed, a series of information which helps the medics to assess the evolution of the patient. And finally, the last visit, date and time, important to avoid visiting the same patient twice during your round. Here we have another screen. This is an input screen on the PDA. And as you can see, it is an extremely simple data collection tool. So it's worth noticing that the patient and location identification always shows on top. The previous status entered for the patient during the last round is shown as a dot next to the option. And also, if you press the number corresponding to the option on the keypad, it has the same effect as tapping it with the fingers on the screen. We only allow users to select one option or select multiple options per screen. So no typing, no writing, which means less errors and less stress while being on PPE. And this is the part I think I like the most, because this is when I get to show you the application I developed, ELEOS. And here we can see a screenshot of one of the dashboards that the clinicians use to check the current location and the status of each patient in the EMC. And what are the big successes of this project? Well, we did see an improvement in the time that the clinician spent entering patient data. It was also very easy for users to learn how to use the system, especially the barcodes, which were of great value, getting information into the system quickly. And we deployed the system very fast and at a very low cost. And what are the things we would like to improve in a future deployment? Well, we need IT skilled people in the field to support the IT infrastructure, but the kind of profile is hard to find during an Ebola break. Also, we experienced connectivity issues between the PDA and the server, and for that we used a buffer to store the information locally so we could send it later on whenever the connection was available again, but then you lose the advantage of the real-time information. And also, as a data collection tool, clinicians constantly change what data they want to collect, and there is not a clear agreement about the patient information essential to collect during an Ebola break. And finally, we must be aware that the situation evolves very fast. because we are having less patients, then we decide to do clinical trials. So in that sense, it's important to do a constant follow-up with the field to make sure to prevent that the information you are collecting becomes obsolete for the clinical setting. So the next steps in this project include the use of other mobile devices such as smartphones and tablets, and we can do this without the costly and time-consuming developing, because we use a technology called MCR, which allows building the mobile application regardless of the operating system and underlying hardware platform. We also source the mobile software to another company, but we are planning to learn this technology in-house so we can have more control over the software and react faster to the needs of our users. And this project was conceived for Ebola, but we are exploring the possibility to use the system in other types of emergencies. With ELEOS, we learned that usually the simplest ideas have the biggest impact. So I strongly believe that the use of mobile devices in MSF operations, and maybe for any healthcare setting, can make patient care management simpler, faster, more reliable, and more efficient. And this, in a situation like we saw in West Africa, can make the difference. Thank you very much.
Thank you very much, Manuel. So we move to some questions, and we're going to go to our online audience first. Go ahead.
I have a question from MSF Zimbabwe, who are asking, what is the backup plan? For example, do you still use paper copies of information?
Yeah, the backup plan would be to go back to the paper collection system, and when we were actually piloting the system, we had some times still using the paper and others using the PDA.
Thank you very much. Okay, question at the back there, on the left-hand side. Please stand up and state your name and who you work for.
Matt, I'm a student nurse at King's College. It's just a quick, one of my placements was actually in the TB team here in London, and one of the things that they were struggling with was dealing with the paperwork of having to test basically a school, 300 kids in about 3 weeks. An awful lot of paperwork was involved in that. Is it possible you could work with other organisations that do similar things, just to, if nothing else, make that process more efficient? This looks all really good. Heck, I would have loved to not sift through 300 plus sheets of paper.
So you ask essentially, is it the role of MSF to... Could other organisations be involved and use similar processes and ideas that you're coming up with?
More general question, could the technology be used elsewhere? So the question is more, could the technology that you use to get rid of the paper system in the field be used for any other paper type system potentially?
Well, of course, this is what we are actually planning now to do in Brussels. We could use it for cholera outbreaks, for malnutrition emergencies, for TB, HIV. Yeah, the sky's the limit. I mean, it's also a matter of getting together with the clinicians, understanding their needs, which is always I think the most difficult part, and then trying to respond to the need with a mobile device, which I think it will definitely improve the operations. Yeah.
Okay, thank you very much. Any other questions? Yep, up the top here on the right-hand side. Please stand up so I can see you.
Hi, it's Leah Lashley from MSF. Sorry, I don't have a voice. Thanks for the presentation. I think this is very needed and very useful. But how much will the presence of a developer be needed once it's adapted to other, or Ebola or non-Ebola? How much will there be an absolute need for a developer in case it's an emergency where we can't get hold of a developer immediately, or the developer's busy with something else and we want to get a project up and running? How much of it is easy to adapt?
Well, I think, first of all, mobile applications are something we can definitely afford to do in MSF in-house, because they are relatively simple, and then, like I said, we can respond faster to a change of requirements that if we outsource the application. Now, the time that we're considering here is days, I would say, maybe even hours, because of this platform that we are using that really allows us to have this application running on an Android, on a PDA, on a Windows Mobile, on tablet. So it's really independent of the device, and that makes actually the development cycle really, really short.
Thank you very much.
Thank you.